Thanks for coming, everyone. Thanks for coming to this session. We're talking about open table formats and lessons we've learned at Snowplow from supporting open table data lake formats. So to start, a little bit about me. I'm Jordan Peck. I'm Technical Account Management Lead at Snowplow. I've worked in digital analytics and data management for 10 to 12 years at this point, working mainly at digital marketing agencies up in Leeds, where I'm from. I manage customers at Snowplow, such as some of the names you see on screen here, like Auto Trader, Burberry, and Charlotte Tilbury in retail, media companies like Condé Nast, DPG Media, and gaming companies like Kindred and PokerStars. And a tiny little bit about Snowplow. Snowplow is a behavioral data platform designed to help you collect data from your websites, your mobile apps, desktop apps, wearables, anywhere where your users interact with your digital platforms, send it to your cloud data platform through to your cloud data warehouse or lakehouse in real time, so you can model and predict on that data in real time. So let's set the scene when we're talking about data lakes and data warehouses. We'll start with a little history lesson. What is a data lake? What do we mean when we say data lakes? So data lakes are not a new concept. Data lakes have been around for a long time. A number of you may recognize things like Hadoop and associated technologies like MapReduce, Cloudera, Hive, etc., Scalding. Data lakes were designed mainly to be on-premise systems to store semi-structured and unstructured data like text files, CSV files, XML, audio, video files, things like that, at very, very large scale and to be very cost-effective. Mainly for doing either very, very simple MapReduce group and filter style workloads or unstructured workloads like ML workloads. But they really rose to prominence through technology such as Apache Parquet. So people could run classic analytical style queries on their data in their data lake. For anyone who doesn't know, Apache Parquet is a open source columnar format rather than a row format like CSV that has a bit of metadata management that helps you compress data and make it efficient to run queries. And it rose to prominence because running analytical queries on unstructured data is very, very difficult and very expensive. And in addition to this, the sort of previous generation of data warehouses like SQL Server and Oracle, Vertica, those on-premise systems became way too expensive to store and process all of the data, the variety, the velocity of data that enterprises were creating and storing. So Apache Parquet and data lakes became kind of the go-to way to store data in a data lake and analyze it. However, despite the promise of Hadoop, Parquet, MapReduce, etc., there were a number of issues when running these classic data lakes. They were very, very complex systems. You needed the data center, you needed a shed load of servers, you needed some consultants to come network them all together. The interfaces to Hadoop, like MapReduce and Hive, were slow and complicated to set up properly. And while Parquet tables are good for analytical style, where you're analyzing a few number of columns, they're very bad at single row operations, meaning that things like making tables append-only. Sorry, the fact that tables were then append-only made things like doing updates or deletes or mutating data in place was very challenging. It made changing schema difficult. So if your data at source changed its format, it was very difficult to sort of gracefully handle that. And the main issue, or one of the main issues, was the lack of transaction controls and no ACID compliance. So again, no updates or deletes. It was very, very hard to ensure consistency if you had multiple writers or multiple readers to know that one query would get the same result as someone else. And then, therefore, upserting data in an incremental fashion was difficult. I'm not going to show the link here, but this is a really, really fantastic story from Eric Byrne, who worked at Spotify in the late 2000s, run their Hadoop cluster. Basically, they were in Sweden. They had a very small server rack in their office running their Hadoop cluster, and a bunch of issues were starting to come up with their Hadoop cluster, and they basically found out that because it was a hot Swedish summer, the sun was coming in through the window and overheating the machines, so they put a blackout blind up to cool the machines down to make sure they worked properly. So yeah, a lot of issues with running these data lakes. And the cloud came along and kind of changed everything, really. No more server racks in a corner that you have to protect from the sunlight. Cloud data warehouses like BigQuery, Snowflake, Amazon Redshift, really the first, made it scalable, easy to use, because all you need to know is how to run a data warehouse and write SQL, but also affordable to run at this scale. And this led to the growth of the modern data stack and all the associated tools like transformation tools like dbt, ingestion tools like Fivetran, data observability tools like Monte Carlo, using reverse ETL to move data out of the data warehouse into operational workloads. Basically, everything started to center around the cloud data warehouse, with more and more workloads and more consumption coming into the data warehouse over time. And that has led to more challenges recently with cloud data warehouses. There's two main perspectives on this from my view. The first is cost pressures, with the amount of data in the warehouse going up, the number of workloads, the number of use cases on the warehouse increasing, and the economy getting worse, money becoming harder to come by, made warehouses more expensive than they used to be. And the sheer variety of use cases, the diversity of use cases, from classic analytical use cases to ML and AI hype cycle has really driven this change in use cases as well for what these warehouses weren't designed for, and the variety of data structures as well. So you're not just working with tabular data, you're working with semi-structured data, maybe you want to work with unstructured data. Things like vector databases or vector formats don't really work in a data warehouse. So today, we want the best of both worlds. We want the scalability, the cost effectiveness and flexibility of data lakes, but we want the structure, the governance, and the ease of use of a data warehouse. And that has obviously led us to the lakehouse dynamic that we're more familiar with today. So let's talk about how modern data lake formats have sort of dragged the data lake into the modern day. There's three big open table formats. There are others, but these are the three most popular ones. Apache Hudi, which was originally developed by Uber in open source in 2017. Apache Iceberg, originally developed by Netflix and open source a year later. And Delta Lake, developed and actively managed by Databricks. So these formats, I'm not going to go into the technical details of all three of these because we don't have time, but they're all built on top of open source projects, mainly Apache Parquet, also Apache Arrow, but they're all built on top of Parquet most of the time. But how they all handle the metadata of those Parquet files is different by each open table format. How they are accessed, how the query engine scans the data, how they are merged and managed over time. There are differentiating features, and they were all built by these different companies for different purposes. So Iceberg, for instance, supports partition evolution, which most of the other formats don't. Hudi has this cool merge on read format, where basically when you run a read query that merges data, it will log it later, so when it compacts, it will actually compact that read together. And Delta Lake obviously has really tight integration with Databricks, things like Unity Catalog. So the modern day open table formats give us many nice advantages. So partition pruning, this is where it can basically not look at a bunch of data if it's not relevant to your query. Some will do even within a partition, and file skipping. It brings ACID compliance, so you can have confidence that multiple writers and multiple readers will get consistent results. It gives you things like time travel, so like if you want to go back to a previous state of data or compare that to today, or you accidentally dropped a table by mistake, you can recover it because the way the metadata is handled, the actual original data is still stayed in place. We get graceful schema evolution, so we can mutate columns over time as our schema changes. And it gives us support for multiple different query engines. And this is great because not only is the storage in the lake on S3 or Google Cloud Storage or Azure Data Lake Storage extremely cost efficient, and you can still get really good performance with the modern day query engines and how they handle metadata. You also get this lovely flexibility, and it removes vendor locking. We actually have a customer who is using Delta on GCP, who are using BigQuery to query that data for BI purposes, but then Databricks to read the same data in place for some Delta Live Table use cases and data science use cases. So they get really, really nice freedom this way. I don't know who's in from Big Cloud Platform, but they don't particularly like this because they like the vendor lock-in. Alongside your open table format, you'll also need to make sure to choose a metadata catalog. So the open table formats do store metadata within their own format, but the metadata catalog is an even higher level of metadata. It acts like an API between the open table formats and the Parquet files, and your query engine. So it'll say where the physical location is, what the S3 location is. It'll do access rights and permissions and column level security. It'll store column level statistics to help the query engine know where to go look. So the query engine and the metadata catalog work in tandem to efficiently and effectively query your data in your lake. So, based on all of that, you might be thinking, well, this all sounds great, right? Let's abandon using data warehouse and go all in on open table format if it's cheaper and faster and more flexible, right? But there are a few things that you need to bear in mind before making this decision. So first, you should choose your cloud. Now, this for most companies will be relatively easy. Most companies are single cloud, although there are many companies who work in a hybrid cloud solution. So first of all, choose the cloud that makes most sense for your data workloads. And then you can choose your query engine. Number of logos here on the right-hand side. So whether you're a Snowflake house or you're one of an open source thing like Trino or Presto, you can make your choice pretty independently. These two are relatively decoupled. With some exceptions, if you're on Amazon, AWS Athena might make some sense, or maybe you want to run a managed version of something open source like Spark. So either use Spark or Databricks, or maybe something like Dataproc on GCP or EMR on AWS. But these are relatively decoupled. Then you can choose your open table format. Now, the open table format may be influenced by what you're trying to do, but may also be influenced by the query engine you chose in the previous step. So Snowflake, for instance, have aligned themselves very closely with Apache Iceberg. Databricks develop Delta, so that will probably make a lot of sense, though. You do have to be careful, though. Some query engines only support read, not write in those table formats. Hudi is one to be aware of. Athena doesn't support write into Hudi, for instance. It does support reading, though. So you've got your cloud, you've got your query engine, you've got your query engines, and you've got your open table format. And now you've got to choose the metadata catalog that you're going to use with this. And this will be heavily dependent on your choice of cloud and the query engine and the open table format that you chose. So if you're on AWS, should you go with the Glue catalog or something else, like the Hive Metastore, which is still very popular? I mean, Databricks have acquired Tabular recently, who were the original developers of Iceberg. So should you use Iceberg and Tabular with Databricks, even though Databricks develop Delta? Databricks also supports Unity Catalog and the Hive Metastore and AWS Glue. So which one of those three should you use? And basically, if you go through this whole process, it can start to feel like playing like a slot machine or a one-armed bandit. Like basically, you're like pulling this thing, spinning all the random wheels, and hoping that the random selection it lands on is the correct configuration for you. It's the epitome of the tyranny of choice, right? So should you be Databricks on Azure with Delta Lake with Unity Catalog? Should you be Snowflake on Amazon Web Services with Iceberg and Polaris? You may notice the vendor lock-in point I was talking about there as well. Snowflake on Google Cloud with Hudi and the Hive Metastore, or on-prem Spark. It can start to feel like so many different variables have been thrown into this equation, and it's like you're having to, guess and hope that the combination you go with is going to satisfy all of your current use cases and workloads and all of the ones moving into the future. So it can feel like crippling in terms of choice. So what have we learned at Snowplow from supporting open table formats that you may want to bear in mind? So about a year and a half ago, we decided to take on the effort of loading your first-party behavioral data into open table formats on your data lake. So most behavioral data tools load data into their own systems. We have loaded into data warehouses like Redshift and Snowflake and BigQuery and Databricks for several years. But now we wanted to start to give our customers flexibility and loading into these open table formats. And in doing so and developing what we call our lake loader, we came across having to support all of the different 3 clouds that we support, the 4 different query engines that we support, the 3 different open table formats in question, and all of the different catalogs that are compatible with those clouds and query engines, we came across a bunch of these edge cases that might be helpful for you to consider. So first of all, different metadata catalogs on the same cloud operate differently. So if you are loading to AWS, S3 on AWS in Iceberg format, you have to have different considerations if you're using Unity Catalog versus AWS Glue versus the Hive Metastore. They have different authorization methods. Some use REST, some use JDBC. They can store their metadata in different formats. Some catalogs will only work with certain versions of certain open table formats, or only certain features will be available with certain versions of the open table formats with that catalog that you're using. And the query engine that you're using, again, may only support a certain version of your catalog. So there's a matrix of decisions or things to figure out when just thinking about the metadata catalog. That's why I labored the point. Different partitioning strategies. So partitioning is where you basically chunk your data up into different partitions. We have customers, most people choose to partition, say, by day. We have media companies who work in the publishing and media industry who will want to do intraday reporting. So they'll want things like partitioning by hour. But the smaller you make the partition, the harder you make it to run all of these write operations. And then you have to do regular compaction jobs or optimized jobs to squash them all together. Iceberg actually, like I say, supports partition evolution. So if you want to change your partitioning strategy over time, Iceberg does support that. Most of the other formats don't. Delta supports, like if you partition by a generated column, so say date of a timestamp, you can filter on the date column and the timestamp column and get the same partition pruning benefits, but not some of the others don't support it in the same way. So you have to think about your use case and how you decide to partition it, and think if that's ever going to change. I can't show the links, but point 3, high volume concurrent writes and handling duplicates. Whilst the open table formats do provide ACID compliance and ACID transactions, what we noticed was when we were running multiple parallel writers, I think it was into Delta, what we noticed was, one of our engineers noticed that the Delta engine was actually having to do an entire scan of the entire metadata commit log inside Delta every time it committed something. And that could take a long time as the data volume grew, and the longer it took, another writer could essentially get ahead of it, and you end up with multiple writers writing duplicates of the same data. So our engineer, there's a link embedded in this, I'll share the slides after, where our engineer actually wrote a PR to the Delta project on GitHub, made a change to how the commit log would be accessed, which gave, and they merged it into their main branch. We saw really, really good performance improvements when writing at high volume, and hopefully everyone else who was using that version of Delta saw some improvements as well. But yeah, especially if you're doing this, because we write from a stream, so we write from Amazon Kinesis or Kafka or Cloud Pub Sub. If you're using multiple writers at the same time, you can come across this, and there's tuning you can do on the consumer to make sure that you handle those effectively. And one that we really didn't expect to see was your transformation code across the open table formats. So we offer several DBT packages that write SQL code to transform our raw event data into aggregates. And we support Snowflake, Redshift, BigQuery, and Databricks. And we were like, this is going to be great. We can just point the query engine at the data in the lake, and it will work fine. One of the things we found, though, was Iceberg supports in the Iceberg format supports structured objects and structured arrays. So strongly typed nested columns. Snowflake's native way inside native tables to support semi-structured data is a variant column, which is just a JSON blob, which is unstructured. And Snowflake native tables don't support structured objects and structured arrays. So we then had to change our Snowflake DBT code to account for the different format that Iceberg supports, even though Snowflake are the closest supporter of Iceberg and support Iceberg native, Iceberg external tables. So we actually had to figure out how to do that. And then if we want to introduce another query engine, something like Amazon Athena for running queries on Hoodie, on AWS, Athena's SQL syntax is different, so that's a separate layer of support we have to write. Spark SQL is slightly different to Databricks SQL, so we'll have to change the SQL code in our packages to handle this. And then, so you can start to see how complicated just our DBT estate becomes to manage. So that's where we are now, broadly. There's a few more. There's other things we could discuss, but what do I see, this is me personally speaking, as the potential future for these open table formats? So what are the changes that could be ahead of us, and what am I keeping an eye on? So the first one is unified formats. So some of you may have figured out that if all these open table formats essentially sit on top of Apache Parquet, but have different metadata strategies on top of it, and all these table formats are open source, you could just sort of understand those different metadata strategies and leave the Parquet data in place and have a translation layer. And that's exactly what we started to see happen. So Databricks were one of the first that I saw. They launched something they call Uniform. And this is essentially where you can write data in Delta format, but query it from an Iceberg client. So essentially, when you write the Delta file, it'll also write the Iceberg metadata. So your Iceberg compliant IDE or query engine will interpret the Iceberg files and query it as Iceberg. There's another project. There's a company called One House who developed something called One Table, which they've now open source as X cross table, Apache X table. And they were helped developed by Google and Microsoft. And the idea here is that you can have a data in, let's say, Hoodie format, and you can run a single one-off job, and that will convert the metadata from Hoodie to Delta and Iceberg, or one of the other. So you could run that, say, on triggered by an SNS notification or on an hourly cron or something, and then you get the whole. Essentially, you get the benefits of every world, apart from the fact you have to run this job every so often. They're not perfect. You lose certain features. This way, not least because the way the companies who develop the open table formats have made certain features proprietary. What about new formats? So I've mentioned mostly Apache Parquet so far, but technically Iceberg can also support other formats like Avro and ORC as the underlying data format. But maybe there are others. So there's a couple of other columnar store formats that are becoming popular. Nimble and Lance v2 are a couple I've read about. I don't know a huge amount about them, and they don't have a huge amount of adoption, but from what I've read, they have very attractive performance improvements over the way Parquet handles certain things. And maybe could we see completely new formats? So what about vector formats that you can store in the lake effectively and in an open way so that you can be optimized for AI workloads or LLM workloads? These table formats we've been talking so far are tabular, columnar formats, so are still mainly for your traditional group and filter, slice and dice type workloads. So are we going to see like an open vector table format that you can use with your with your different query engines? And then again, diverging from open source. So Delta Lake is a good example. So Databricks open sourced Delta Lake. However, there is a delta between the open source Delta Lake format and the proprietary closed source Delta Lake format, which integrates closer with Unity Catalog and gives you some nice advantages. Are we going to start to see that happen across the other formats by the companies who are developing and maintaining these open table formats? As I mentioned earlier, as alluded to earlier, they're not. You can see why they wouldn't be huge fans of these open table formats. For instance, if you're Snowflake, you may see people moving workloads out of Snowflake compute into a different query engine. So that's why Snowflake have launched Polaris. There are numerous features with Polaris and Iceberg that you don't get from using vanilla Iceberg. Same with Databricks and open source Delta Lake and proprietary closed source Delta Lake. So I suspect there'll be more developments in this area as the vendors try to, quote unquote, lock you back into some of these if you choose to use these open table formats. That's more or less it from me. I'm Jordan. I'm going to post the slides on LinkedIn after, so if you want to follow me on LinkedIn, happy to have you around. I'm with Snowplow. What booth are we at, Adam? We're on the exhibition floor. Come speak to us if you like. Yali, my co-founder, is speaking tomorrow if you're going to be here tomorrow. Thank you very much. I think I've got time for some Q&A. Thanks, Adam. Sorry for putting you on the spot.
Thank you. Great presentation. I have a question for organizations, actually. Are these presentations recorded and posted later?
Yep. Yeah, absolutely.
Okay,
Yeah, I'll share the slides on LinkedIn
this
as well.
was, I think, the best explanation of open table formats I have ever seen.
Oh, thank you so much. There's a question down here, sorry, at the front.
Thank you. You mentioned that you faced some problems with concurrent rights on Delta Lake and how you submitted a patch to sort of improve upon that. Have you faced anything similar with Iceberg, or have you ever experimented with that? Because we are a data platform and we run into concurrent right issues with Iceberg, and we'd like to sort of have some pointers on that.
I've not seen us have the same issue with Iceberg. It may have been down to the customers we're running and the relative volume of data they're running. Also, these guys were on Google Cloud, so it may have had something to do with PubSub. I'm not the engineer who developed it. Essentially, what happened was every time we tried, you did a write and a commit. Essentially, Delta would read the entire commit log within a certain thing, which is extremely costly. And actually, you only need to read like the most recent part of the commit log. So that was the change that our engineer submitted, and that's what Databricks went with. So it's probably something like that. It's when it's accessing all the metadata. One thing I didn't mention is that the metadata is usually stored in something like JSON, which isn't super performant, but it's very, very small compared to the rest of your data. So generally, scanning the metadata is very, very quick, unless you have loads of data and loads of JSON files. So you need to try and almost limit the scan on the metadata log when committing.
Gotcha. Thank you.
Hello. You mentioned that you are using Snowflake with Iceberg and Databricks with Delta Lake. So which use case you would say is better suited for each of these tools, and how did you decide between these two?
Yeah, that's a good question. So all three of the open table formats were built with different intentions. So Hoodie was built by Uber basically to support real-time incremental processing, whereas Iceberg was originally developed for purely analytical queries. They were doing data lake on S3, and their huge column scans were becoming too slow. So Databricks developed Delta to help with uniformity and governance with Unity Catalog and things like that. So if you're using Databricks and running lots of different variety of workloads and you're all in on Unity Catalog, Delta Lake makes a lot of sense. If you are doing just OLAP style, group and filter, scale type analytics, but on enormous volumes of data, Iceberg makes a lot of sense. It's fair to say that they're very, very similar formats, but they are developed with different purposes in mind. And people who are closer to the projects than I am, say that the types of changes that they're making and stuff like that do still follow those original tracks quite closely. So it's worth looking into the specifics of what the different formats are better for.
Okay, thank you.
Hi, specific question to Apache Parquet. One of the deficiencies in the project is that the footer metadata is scaling linearly to the number of row groups you have. I'm wondering if any of the formats which you've mentioned address this issue. And a second question, unrelated, in terms of vendor lock-in, do you see the vendor lock-in adding proprietary metadata that assists with queries only, or is it actually making changes that could, in fact, make it very difficult for projects like Apache Xtable to convert it into different open formats?
Okay, so the Parquet question. So the idea is that when you query the open table format, you almost don't, initially you don't scan the Parquet files at all. So the fact that the metadata in the Parquet file scaling inefficiently is not so much of an issue. It's also why these other formats like Nimble and Lance v2, the way they handle their own metadata inside the data format, is more efficient. you'd have to get into the specifics of each open table format and how they. So for Iceberg, for instance, we'll create like V1, V2, V3 metadata JSON files, but then there's a version hint file, which says like the most recent version of the metadata file, so the query engine knows which one to skip to first, which help in those ways. And on the vendor lock-in part, I mean, it's tough to say. It's tough to say, really. I could definitely think of like how Databricks may look at developing something that will help with AI and ML workloads outside of the classic, OLAP style queries, because of the fact that Unity Catalog not only stores tables and columns, it stores models, version of models, jobs, and everything like that. So they're aiming at the governance perspective. So I think it also leans more towards what those big platforms are trying to do with their own platforms. Sorry, I can't be more specific.
Thanks, Jordan. That was a really great presentation.
Thanks.
I kind of wanted to ask, you did a great job of describing the pitfalls and differences between data lake formats. And it might just be that's what you've been focusing on. But do you have any advice on when you've chosen a format, what are the pitfalls you see people when they're actually implementing their data lake, at an individual business or organization level? Do you have any advice?
I think the most sort of pressing, I'm not sure I'd say a mistake, but the sort of most pressing issue I've seen customers have is choosing an inefficient partitioning strategy. So even then, if you partition by day and you want to run queries in the last 15 minutes, then you're going to have to, you're a large daily volume of data, then you're still going to have to scan a day's worth of data every time you only want the last 10 minutes of information. So getting an efficient partitioning strategy for your query pattern is, and Iceberg does support partition evolution, but it's not completely straightforward. It's better than doing it with Hadoop, because you'd have to, or with Hive or something, because you'd essentially have to repartition the entire table. And if your entire table is a petabyte worth of data, then that's like weeks worth of time for the query to run. But yeah, that's probably the most practical thing I've seen kind of people come into issues with, and trying to alter their partition strategy over time.
Okay, I have to finish there, I'm afraid.
Thank you, everyone.
Yeah.